Hello everyone. Today we are going to explore two the most important components of computer system, primary memory and cache memory. These two types of memory play a key role in how fast efficiently a computer performs. They might seem similar but they have very different purposes, speeds, sizes and locations in the computer architecture. Let's begin with primary memory. Primary memory detail explanation. Primary memory is also known as main memory or internal memory. It is the memory directly accessible by the CPU while performing operations. This memory holds the operating system, application programs, and data that are actively being used by the system. Importance. Think a primary memory like your working desk. When you are working, you place everything you need right in front of you books, papers, pens, etc. You don't keep going to your shelf like hard disk every time you need something. Similarly, primary memory gives the CPU quick access to data, avoiding the slower hard disk or SSD. There is a characteristics of primary memory. It is volatile, means the data is lost once the power is turned off. It is faster than secondary memory but slower than cache. It is temporary, that is used only during active sessions. It plays a major role in multitasking since it handles all the currently running processes. Types of primary memory. There are two main types: RAM, that is random access memory, and ROM, that is read only memory. In RAM, used to store temporary data for currently running programs. There are two subtypes of RAM: DRAM and SRAM. DRAM means dynamic RAM, that is most commonly used, and SRAM is faster and more expensive. RAM is wiped clean when the system is shut down. And in ROM, that is read only memory. Non volatile retains the data even when the power is off. Contains the permanent instructions required to boot the system. Data in ROM is usually not modified. Through we have programmable ROMs like EPROM. Size and speed. RAM size is in modern computers range from 4 GB to 64 GB or more. While RAM is fast, it still takes longer for the CPU to fetch data from RAM than from the much smaller and faster than cache memory. Cache memory. Now let's move to cache memory. The secrets behind the high speed processing. Cache memory is a very small, ultra fast memory located inside or very close to the CPU chip. It is purposed to store frequently accessed data and instructions so the CPU can retrieve them quickly without going to RAM. Let's go back to our earlier example. If your disk is primary memory, then cache memory is like keeping a sticky note with important formulas or passwords right under your hand. The fastest access possible. Without cache, the CPU would waste time repeatedly fetching the same data from lower LAN. With cache, that access time is reduced to nanoseconds. Types or levels of cache. Cache memory is typically divided into three levels: L1 cache, L2 cache, and L3 cache. In L1 cache, that is level 1, closest to the CPU core, extremely fast but very small, typically 8 KB to 64 KB. Each core has its own L1 cache. In L2 cache, slightly larger and slower, ranges from 256 KB to 1 MB, may be shared between cores or dedicated per core. L3 cache, much larger, up to 32 MB or more, and shared among all CPU cores, acts as bridge between L2 cache and RAM. Then there is a characteristics of cache memory. Here feature and description is given. Speed. Cache memory speed is extremely fast. Size very small. Cost more expensive than RAM. Location inside or near the CPU. Volatility. Yes, data is lost when power is off. Conclusion. In summary, both primary memory and cache memory are vital for the performance of computing device. Primary memory acts as the main workspace of the system, holding all active data. Cache memory ensures the CPU doesn't waste time fetching the same data again and again from RAM. Balancing of both a large enough RAM and smart cache system ensures that your computers perform quickly, smoothly, and efficiently. Thank you for watching the video.